Howdy, I'm Professor Rad, and today we're going to talk about the power property of exponents. So, just like when we defined the product property of exponents, we did a little experiment to start. We're going to do the same thing here. So, let's try to simplify 3 squared to the 4th power. Now, notice that this part is all in parentheses. That means we're going to take this whole chunk and raise it to the 4th power. In other words, we're going to take 4 copies of this piece that's in parentheses. So we need 4 of these being multiplied together. And on the inside, we have 3 squared. Okay, now to break this down even more, 3 squared is the same thing as 3 times 3. So within each of these parentheses, we have 3 times 3 happening. Okay, so at the end of the day, all we have is multiplication happening here. And we're multiplying 1, 2, 3, 4, 5, 6, 7, 8 copies of 3. So we end up with 3 to the 8th power. Notice that the way we've written it, we've got 4 groups, and each group has 2 items. So when you have repeated grouping like that, that's the same as multiplication. In other words, when you have a power raised to a power, you can multiply the powers to get your answer. So here we have 2 times 4, that's going to give us 8. So because this property helps us simplify a power being raised to a power, we're going to call it the power property. So the power property of exponents states that when an exponential expression with a positive base has a power raised to a power, the result is equal to that same base raised to the product of those 2 powers. So let's go ahead and apply this property to simplify some expressions. Here they want us to write each expression with a single exponent. In part A, we have 5 cubed being raised to the 8th power. So we have a positive base of 5, and we're raising a power to a power. So this is the same as 5, and then we can multiply these 2 powers. 3 times 8 is 24. So 5 cubed to the 8th is the same as 5 to the 24th. Let's take a look at part B now. In part B, be careful, we don't have a negative base here because this minus sign is outside the parentheses. That's the additive inverse. It's basically there just to trip us up here, and really we can ignore it until we're done with the problem. So let's ignore it. My base is positive of 3, and then I can multiply the exponents. 2 times 3 is 6. Now we can bring down that additive inverse, and we have the additive inverse of 3 to the 6th. All right. We've got 1 left to go. Here we have 2 times 2 to the 5th to the 7th. Okay, well, I'm seeing 2 things here. Thing number 1, I'm seeing 2 without an exponent written, so I'm going to put that invisible 1 there so I don't forget about it. And then I'm seeing that part of it is going to use the power property, but then this part isn't because it's not being raised to another power. So let's deal with the part that's using the power property first. So my base is 2, and I'm going to multiply those powers. 5 times 7 is 35. Now I'm going to bring down what I had before, the 2 to the 1st times. Okay, now I notice both of these still have the same base, and they're both positive, and now I'm multiplying. So instead of applying the power property, I can apply the product property here, which says I can keep the base and add the exponents if I'm finding a product, if I'm multiplying. So 35 plus 1 is 36. So 2 to the first times 2 to the fifth to the seventh is the same as 2 to the 36th power. Let's go back now and see if we can experiment with one of those questions from the product property of exponents examples, where the product property wasn't enough, but I bet we could try and use what we learned from our experiment here to help us solve that. Okay, so here's the example we had been looking at that we couldn't apply the product property to because we had three different bases, a 2, a 3, and an 18. But we said 18 was the same as 2 times 3 times 3. We found the prime factorization. So we split this 18 to the 7th up into 2 times 3 times 3 to the 7th power. And then we were kind of stuck because now we have multiplying in parentheses with an exponent out top. Now, the power property doesn't apply here either, but when we established the power property, we took that power and we created that many of those groups together. So let's try that here as well. So because we have a 7 here, let's write out 7 groups. So 1, 2, 3, 4, 5, 6, 7. I ran out of room. Okay, so we've got our 7 groups going. And in each of these 7 groups, we need to have 2 times 3 times 3. So 2 times 3 times 3 is going to be in each of these. All right, so now we have just a whole bunch of stuff being multiplied. So we can count up how many 2's there are and write that in exponential notation, and how many 3's there are and write that in exponential notation. So we've got 1, 2, 3, 4, 5, 6, 7 2's. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 3's. So it looks like 18 to the 7th is the same as 2 to the 7th times 3 to the 14th. Then we can bring this 2 to the 7th down that we started with, and this 3 to the 7th. And now we can simplify. So I have 2 to the 7th times 2 to the 7th. Remember, with the product property, you add the exponents. So that's going to give us 2 to the 14th. And then we have 3 to the 7th and 3 to the 14th. So we can add the exponents, 7 and 14, and that's going to give us 21. So we can use a combination of properties as well as techniques we discover when we determine properties to help us simplify expressions like this. Now, in my arithmetic class, I'm not going to ask you to do anything like that. Basically what we did in this last video, and we said now we can't do anything with that, that's basically what we're going to be looking at. But I did want to show you, like, this is the kind of stuff that mathematicians do, is they try and see, is there any way that we can take this long expression and make it look a little bit neater based off of things we know, and try and develop new techniques. That's the whole point of properties, is just trying to make things look nicer and find some shortcuts to make lives a little bit easier than they are currently. So For the last Now You Try for this chapter, we've got 6 expressions, and we're going to use the power property to simplify each of these. So I hope you have a fantastic day, and I will see you in chapter 5. Bye, everybody.